So now we're going to talk about properties of matter. And the important thing about properties of matter is that almost all of modern physics is encompassing properties of matter, with the exception of maybe relativity. Starting with the I'd say probably early 1800s, moving on to the 1900s, and even now, we're still trying to explore what matter is. Okay, so we have this desire to understand what everything is composed of, and that has led basically physics to what it is these days. I mean, most of what we concentrate on physics is what is matter. What is it composed of? How does it function? I mean, is it nothing more than light, or is there something more there? We don't know. Okay? So what I'm going to do is I'm going to go through a series of experiments that kind of evolve our point of view on what matter is. Okay? The first one is using magnetic fields and electricity. Okay, so what we end up doing is we end up having to have a device that has a voltage. Oh, I need to put the slit on the bottom. Okay, and it has a filament here. Cool. So there's a voltage across here, and then there's a filament right here. Okay. Well, that filament is designed to get incredibly hot. It gets hot and hot and hot, and it ejects particles out that way. Okay? Superheated particles. Superheated charged particles. Because the voltage is going to drive that particle. Okay? So it's got to be charged. If it's not charged, you're just heating it up, and it really doesn't want to go anywhere. But once you expose it to a voltage, if it has a charge, it gets ejected. So this particle then is ejected and then subject to a magnetic field, which forces it to make a circle, to spin around in a circle. Okay? So what you can do is that you know that the current of that the current that's used to create that magnetic field will determine the magnitude of that magnetic field, the strength of it. So you know the value of M, you know the value of V, so the charge times V is the amount of energy it has. You have this field in here. It's experiencing uniform circular motion, which we know to be V squared over R, and we know that this has an energy of charge times voltage, which is going to be converted into kinetic energy, 1/2 mv squared. And we go through this process, and eventually we get to a point where that we can compare the radial value of this circle that is being created by these charged particles to kick out, and we could determine basically the charge to mass ratio of all the particles that come out. Okay? Cool? Now how is this useful? Well, it's useful in one way. If we know the charge value of a single electron, because that's what is getting baked off the filament. It's not protons. Protons don't like to move. You eject the electrons out of here and you get this circle that's being formed. You know the charge to mass ratio of it. If you can determine through another set of experiments the charge value of an electron, you can determine the mass value of an electron. Okay? So this is a really kind of, it's ingenious, really, because you're exploring how this centripetal force that's being created creates a value that gives me the charge to mass, and from that I'm able to determine the mass of an electron. Okay? So that first experiment gives me the idea of how massive an electron is. Well, that's great. That's great, because once I know the mass of the electron, I can compare what I believe to be the mass of an atom. Okay? So you get these charged electrons coming out there, and you know the mass of the electron. So you know the mass of the electron. But now you're comparing that mass with the mass of the atom, and you realize that the electrons have very little mass compared to the overall value of that atom. Also, you notice that it's almost always negative charges that are being produced, that are always being kicked off. So you have to come up with a reasoning. You have to think your way through this and go, well, what happens to the positive charge? We know when we look at an atom, it has no net charge. And then we can liberate these electrons and it has a positive charge. We know that from chemistry. We've known that for a long time. But where is this positive charge and what is it doing? Okay? So we come up with the first example of what we think matter is. Okay? And that will be in the next video.